In this video, we will continue with the plug. We have to finish up with the holes. We need to change the material. I'll show you how to do that. Then we're going to put this part onto a drawing sheet file and dimension it. And I'll show you how to do section views. So actually looking at the part again, I actually realized that I could have done that 0.125 hole all the way through during that first sketch. We didn't. We made it solid, but now we just have to create that hole now. Not a big deal. And on the other side, we can see a hole with kind of like a tapered off end. And we can see some weird symbols, right? We see a diameter of 0.5, and then we see like another weird symbol that says 1.125, and then we have a diameter 0.15 with another weird symbol, 90 degrees. So what does all that mean? All right, I'll show you now. I'm going to hit Shift and the middle scroll wheel to see the back side of it. And I'm going to hit Hole. Remember, when you hit Hole, the first thing it's looking for you to do is say, okay, where are you putting this hole? So you will select that face. Next, you are going to specify where the center of this hole is. You can either be doing it as references, if it's linear. If you have some perpendicular lines, you would be doing that one. In this case, we are locating this hole by saying it is going to be concentric to a different circle on our part. Again, concentric means two circles with the same center. So I'm just going to select this outer circle because I want the center of this hole to be the same as this circle right here. Up until this point in class, the only holes we've done are simple straight holes going kind of all the way through. But we actually have several other types of holes that we can choose from. So we've only done simple hole. We can also do like taped holes, like with threads. We can also do taper tapped hole. Did I say taped? I meant tapped hole. Taper tapped hole right here, where it's kind of doing both moving in at a taper angle and as well as giving you grooves for your screws. You can also have different seats, counterbore, spot face, and then countersink. And then over here, we have different terminations. So this one is actually still going to be a smooth hole. The only thing that's different is we're not going all the way through. So instead of going through all, I'm just going to give it a distance. And that distance, you need to specify. So that distance is, if you look at it, once you hit that over here, you are given the option to choose the different dimensions. So the distance right here, and makes it nice and easy for you, is 1.125. The diameter at the top is going to be 0.5. And you can leave the 118 degrees right there. And let's give this a nice little side view to see if it looks about right. And it does. So that's it. Actually, it wasn't too bad, right? Just to show you, had you done like a counter bore, it just gives you additional dimensions to specify. Okay. And it's there. And now I'm just going to do another hole on this side. And this one is going to be just a simple through all hole. And notice how once you do through all, that like bottom part goes away because there's no chance for the taper off. So we're going to have it go through all. And that distance is, or that diameter is 0.125. And it goes all the way through. And we are good. Okay. It does seem as though we have a chamfer at the end. So before we forget that, let's hit chamfer. And it's a 45-degree chamfer. So the default is 45 degrees, but you can actually do different kinds if you want to specify the distance or the distance and an angle. So the distance seems to be 0.094. I think I typed that in wrong. And you can just click on that end right here. And that didn't work. There it goes. And you can hit apply if you wanted to do several, or you could have just hit OK if you were done. Okay, I think that's it for the part itself. The next thing is I want this material to be shown as, I think it was bronze, right? So to change the material is actually pretty simple. I had this toolbar up here. Can I move this toolbar? I'll just move maybe the inventor thing. Nope. All right, now I'm making a mess of things. Oh, come on, go. This is like being mean to me right now. Just let me click on you. Really? Like, this is where I'm getting caught up on? There we go. Okay. To change the material, it's very simple. All you have to go up here, you can see two drop downs. One is for color. That's this one right here is for color. You can click that drop down and you can choose whichever color you want. Makes it look nice and pretty. Maybe not always. And if you go back to the top, you can go back to the default. On the left, lets you choose the material. Let me verify the material. Should be bronze. So we're going to hit this drop down and we're going to go down to bronze. I don't care which bronze. Nah, that one's kind of ugly. How's the other one? Okay, no difference. All right, I don't care which bronze you use. Okay. The reason why choosing the material could matter is if you were actually going to be manufacturing this part in the real world, knowing or specifying what material we are using, you can also get more information out of Inventor from this. So we're going to go over to your right-hand side. And in the top is the name of the part. This part is unnamed. Part 10 was a default name. Once you save it, that name will appear right here. If you right-click, you can see what's called iProperties. Another way to get to iProperties is to go to File, iProperties. And if you go all the way to the back to Physical, you can see the material. And once you have the material there, you can then, it knows what the density of the material is. It could then calculate what the mass is, what the area is, what the volume is, and the center of gravity. So guys, in this class, we probably touch on the bottom 10% of what Inventor can do. Inventor can do a plethora of things, such as stress analysis, finite elements. Like, there's a lot of advanced statics and mathematics this thing can do. We don't even touch near that. Like, you can figure out when it's going to fail, when you apply a load. But for now, it's just good to know that if you specify the material, you can learn the mass, area, volume, and other physical properties of it. So I'm going to save this part now. And we'll call this, in all caps, the plug. And I guess I'll end this video here, and then we'll have a part 3 where we will put this on a drawing sheet.